A mass of 2 kilograms is attached to a spring with constant 32 newtons per meter and comes to rest in the equilibrium position. Beginning at time t equals 0, an external force equal to F of t equals 68 times e to the negative 2t end exponent times cosine, open parentheses, 4t, close parentheses, is applied to the system. Find the equation of motion if there is no damping. What is the transient solution? What is the steady state solution? Let's first write the equation we are working to solve based on a mass of 2 kilograms, a spring constant of 32, and the external force we're given. Our equation, and no damping, that's also something. So that tells us our equation is 2 times the second derivative of x plus 32 times x equals 68 e to the negative 2t end exponent times cosine, open parentheses, 4t, close parentheses. Considering the complementary equation and finding the characteristic equation for that, we see we're going to have 2 lambda squared plus 32 equals 0, which means that lambda is equal to plus or minus 4i. So this tells us our general solution is of the form c sub 1 times cosine, open parentheses, 4t, close parentheses, plus c sub 2 times sine, open parentheses, 4t, close parentheses. Right. Now also, because of the external force that we see applied, that gives us an estimate, a guess, as to the form of our particular solution. So we're going to call this x sub p of t is equal to a e to the negative 2t end exponent cosine, open parentheses, 4t, close parentheses, plus b times e to the negative 2t end exponent times sine, open parentheses, 4t, close parentheses. Now what we need to do, now I'm going to do this very much line by line, we need to find the second derivative of this so that we can evaluate it into the original equation we have. So the first derivative, x sub p prime of t, will be equal to negative 2a e to the negative 2t end exponent cosine, open parentheses, 4t, close parentheses, minus 4a e to the negative 2t end exponent sine, open parentheses, 4t, end parentheses, close parentheses, minus 2b times e to the negative 2t end exponent times sine, open parentheses, 4t, close parentheses, plus 4b times e to the negative 2t end exponent times cosine, open parentheses, 4t, close parentheses. Because of the product rule, the number of terms should double, right? Every term should produce 2. So the second derivative is going to be quite long, and I'm not going to combine terms until the end because I make less mistakes that way. So x sub p, and the second derivative of that, of t, is equal to 4a e to the negative 2t end exponent times cosine, open parentheses, 4t, close parentheses, plus 8a times e to the negative 2t end exponent times sine, open parentheses, 4t, close parentheses, plus 8a e to the negative 2t and exponent sine, open parentheses, 4t, close parentheses, minus 16a e to the negative 2t and exponent cosine, open parentheses, 4t, close parentheses, plus 4b times e to the negative 2t and exponent times sine, open parentheses, 4t, close parentheses, minus 8b times e to the negative 2t and exponent times cosine, open parentheses, 4t, close parentheses, minus 8b e to the negative 2t and exponent times cosine, open parentheses, 4t, close parentheses, minus 16b times e to the negative 2t and exponent multiplied by sine, open parentheses, 4t, close parentheses. Okay, 8 terms. We had 4, and we started with 2. So, okay, that works. Now, we can combine terms in each of these. So, I'm going to go ahead and rewrite the second derivative of x sub p as open parentheses negative 12a minus 16b, close parentheses, e to the negative 2t and exponent cosine, open parentheses, 4t, close parentheses, plus, open parentheses, 16a minus 12b, close parentheses, times e to the negative 2t and exponent sine, open parentheses, 4t, close parentheses. Okay. I may also combine terms in the first, in just the function itself as well. Oh, actually, no, I don't need to do that. Okay. So, now that we have these things, we'll substitute these into the equation we had. 2 times the second derivative of x plus 32 times x equals 68 times e to the negative 2t and exponent times cosine, open parentheses, 4t, close parentheses. All right, and that produces this equation. It's going to be a little bit long, but the open parentheses negative 24a minus 32b, close parentheses, times e to the negative 2t and exponent times cosine, open parentheses, 4t, close parentheses, plus, open parentheses, 32a minus 24b, close parentheses, times e to the negative 2t, and exponent times sine, open parentheses, 4t, close parentheses, plus 32a times e to the negative 2t, and exponent cosine, open parentheses, 4t, close parentheses, plus 32b times e to the negative 2t and exponent sine, open parentheses, 4t, close parentheses, equals 68 e to the negative 2t and exponent cosine, open parentheses, 4t, close parentheses. From this, we can equate coefficients to see that, if we go ahead and combine some of these, we see that 32a plus 8b must be equal to 0, and also 8a minus 32b must be equal to 68. And we can solve this by substitution or elimination or something like that to see that A will be equal to 1/2, B will be equal to -2. So this gives us an equation of this. X of t equals c sub 1 times cosine, open parentheses, 4t, close parentheses, plus c sub 2 times sine, open parentheses, 4t, close parentheses, plus 1/2 times e to the -2t, end exponent, cosine, open parentheses, 4t, minus 2 times e to the -2t, end exponent, sine, open parentheses, 4t. Now what we need to do is take our two known values. That is, that x of 0 equals 0. Going back to this, it comes to rest in equilibrium position. So at time 0, the position is at 0 in relation to equilibrium. And also, let's see, it comes to rest there. So that also means x prime of 0 equals 0. So let's go about finding what C1 and C2 are. So x of 0 equals 0 means that C1 plus 1/2 equals 0, which of course means that C sub 1 equals -1/2. And that's actually all we can determine from x of 0 equals 0. However, x prime of 0 equals 0 gives us a much more complicated equation. We have to find the derivative, but once we find that derivative, our equation is 4 times c2 minus 1 minus 8 equals 0, which tells us that c sub 2 is equal to 9/4. So our final particular equation of motion is x of t equals -1/2 times cosine, parentheses 4t, close parentheses, plus 9/4 times sine, open parentheses, 4t, close parentheses, plus 1/2 times e to the -2t, end exponent, times cosine, open parentheses, 4t, close parentheses, minus 2 times e to the -2t, end exponent, times sine, open parentheses, 4t, close parentheses. All right, that's our equation of motion. Now, two things we have to answer still, and that is, what is the transient solution? What's the steady state solution? The steady state solution is the portion of this equation that had a C1 and C2. It's from the general solution. So this is the steady state. So that's the first two terms of our final answer here. And the transient solution is the last two terms of that equation that we stated just a second ago, the last two terms of x of t.